Alright there, now it's time for some more lecture videos. This is going to be over chapter 9. Now I know this is going to seem a bit off, but I'm not going to start in 9.1, which I know you're thinking is where I should start, but I'm cutting 9.1 from the course because you don't really need it. There's just a couple things in there that you need and you can get them as we move along in the rest of chapter 9. So I'm actually going to start in 9.3 and I would recommend you start there as well. Alright, so keep in mind while we're doing this the box of beads that we talked about in chapter 8 because we're going to harken back to that through a lot of this right here. As a matter of fact, let me go pull that website up. There we are. Let me remind you. I have a big box of beads in my office. There it is. Looks like that. And I use beans, as in the things you eat, for some, and I use beads in the other ones, so just bear with me. Alright, so from section 8.2, we wanted to know the true proportion of red beads in the box. Suppose you reached in with your scoop and you got 30 red beans and 90 white beans. Let me remind you, right? There's the box. You take a scoop out. Okay? Alright, so what parameter are you trying to estimate? Now let's remind ourselves just for a second what parameters are. So parameters, there's really four. So there's the mean, there's the proportion or percent, and then there's sigma or sigma squared. Those two kind of go together because if you know one, you know the other, since they're squares of each other. So of those four, which one is the one we're trying to estimate, and what is its symbol? Well, since we're trying to estimate a proportion, it's p. That's the parameter we want. Let me just write it out what it is. It'd be the proportion of red beads, or beans, whichever, in the box. Okay, what was the total number of beans in our sample? Well, I had 30 red beans and 90 white beans, so that would make 30 plus 90, which would be 120. What was the total number of red beans in our sample? Oh, sorry, I forgot. What was the mathematical symbol for this? It's n, right? Because it's your sample size. All right, now what about this? The total number of red beans is x, which is, lowercase x, which was 30. That's the number of red I had. So what's our best guess for what the population proportion is? Our best estimate for the proportion of red beans in the box. Well, that would be p hat. We learned about that in 8.2. It has a formula, x over n, which is equal to 30 over 120 in this particular instance, which would be 0.25 if you found it in a decimal, right? Right. So sample proportion, p hat, estimates the population proportion, p. Do you know what p actually was? Well, no. I mean, if you don't pull up this box and count every single bead in here, you don't know. And of course, the beads are just a metaphor. I mean, let's pretend, bring it back up. The white beads are the people that are going to vote for, I don't know, a new tax, and the red people are the people that are not, right? Or the white people are the people that are going to give away Christmas presents this year, and the red people are the people that are not. Or, I don't know, the white people are the people that think Alana's awesome. You with me? Okay. And of course, nobody would be red because everybody knows I'm awesome. All right, now do you expect the actual proportion of red beads to be exactly what we found? Well, of course not. Right? Of course not. But P should be close to P hat. Oops. P hat. That's the way we write it if we're going to write it. Right? As long as our sample was random and unbiased and all that good stuff. Cool. There we go. All right, that's the end of that page. I'll be back for the next page in a minute as soon as I figure out my pagination here. See you, bye.